Hello everybody, welcome back. We're still continuing with our June examination question paper. We are now on question number 4. All right, let's get into business. We're given the function of f and g. F is defined by minus x plus 1 and g of x is defined by 2 into x plus 1 all squared minus a. Now the first question, it says determine the turning point of the graph of g. Okay, remember that. Let's remind ourselves about this question here. Remember that when you're given a function of f, which is given by the form a into x minus p all squared plus q, as long as your equation of the function is given in this format, this p and this q, they are your turning point. So the turning point of our graph here, it is going to be p and q. Now here's one important thing that you need to remember, especially about this part here. For you to find the x turning points, just take whatever is inside the bracket, x minus p, equate it to 0, and then solve for x. You'll find that the value of x is equal to p. So most of the time, for you to avoid this, we just say that if it is negative, when you put it inside, make it positive. If it's positive, when you put it inside as a turning point, you just make it negative. But I think it's much more easier if you can just take whatever is inside the bracket, equate it to 0 and solve for x, and then you take this as the x coordinate of your turning point, and then you write it as your turning point there. Okay, so now let's just answer the question. So the function of g the function of g, it is given by 2 into x plus 1 all squared minus 8. So this is my y turning point and this is my x turning point. For my x turning point, I am going to take x plus 1 equated to 0, and then I'll see that the value of x is negative 1. So when I write down my turning point, I'm going to write them as negative 1 and negative 8. So these are my turning point on the graph. Great. Looking forward, 4.1.2, they are asking us to determine the x-intercept. So remember, when you're looking for the x-intercept, what do? You must let y to be equal to 0. So we're going to take this equation here, which is given by 2 into x plus 1 all to the exponent of 2 minus 8. You take that and you equate it to 0, and then you solve for x. There are two ways that we can find the x-intercept here, so let's just call this one here option number 1, which is the one that I find to be very much easier. You're just going to transpose 8 to this side, so you're going to have 2 into x plus 1 all squared, it is equal to 8. Divide both sides by 2, then you will find that your x plus 1 all squared, it is equal to 4. Get rid of the square here by introducing the square root on both sides of the equation. Then your x plus 1, it is equal to plus or minus 2. After finding that plus or minus 2, then you solve for x. Okay, we start here and say that x plus 1 is equal to the positive of 2, or x plus 1 here, it is equal to that negative 2. And then when you do your transpose here, you'll have 2 minus 1, which is 1. Or here, x, it is equal to, you're going to have minus 1. On the other side of the equation, minus 2 is going to give us minus 3. You see that, right? So which makes our x-intercept to be 1 and 0, and what else? Negative 3 and 0. Remember, we said that y is 0, so here is our x-intercept. Now option number 2, which you are more likely to use, is for you to expand what you have inside the bracket. So on the formula, or on the equation, x plus 1 to the exponent of 2 minus 8 equal to 0. What you're going to do, you're going to expand here. So you're going to have x plus 1 multiplied by another x plus 1 minus 8, all of this is 0. And then when you do your multiplication, make sure that you do it correctly using the FOIL method. You are going to have x squared plus 2x plus 1 minus 8 equal to 0. You must simplify this until it's in a standard form. So you multiply everything by 2. You're going to get 2x squared plus 4x plus 2 minus 8 equal to 0. And then the standard form will be given as 2x squared plus 4x. This is going to give us minus 6 equal to 0. Now once you are here, please use the formula. Please use the formula, the quadratic formula. This is in a standard form. And then upon completing this one in a standard form, you will find that the values of x is 1 and another value of x is negative 3. At the end, they're going to give us the same answer. Yes, great. So that is option 1 and option 2. But you're more likely to use this one. But if you use this one, you can adopt this and just, yeah. Let's move on. So I'm going to clear up everything so that we can answer 4.1.3. So 4.1.3, the question says, determine the point of intersection. What is the point of intersection? The point of intersection is where the two graphs meet. And where the two graphs meet, it simply means that the two graphs are equal. Ne? So that's the whole point of intersection, is where the two graphs are equal. So we're going to equate the two graphs, the graph of f and the graph of g. So the graph of f is given by negative x plus 1. This is equal to 2 into x plus 1 all squared minus 8. Already this one we have simplified, so I'm just going to rush through it very quickly. Okay, on my left hand side I still have my negative x plus 1. This is equals to 2 into, when you expand this and do the multiplication, remember we got x squared plus 2x plus 1 minus 8, and then you multiply everything by 2. You're gonna have 2x squared plus 4x plus 2 minus 8. Look what I'm going to do. I'm going to take this positive 1, I'm going to take it to this side, it becomes negative 1. I'm going to take negative x. When I bring it to this side, it becomes positive x. So that means this side I'm left with 0. And then I'm going to have a 2x squared, and then you're going to have 4x plus x. 4x plus x are going to give us 5x. And then 2 minus 8 minus 1, it is going to give us 7. It is going to give us negative 7. So we are going to have negative 7 here, then everything else is equal to 0. Because 2 minus 8 is minus 6, minus 1 is minus 7, then everything is equal to 0. Then, guys, let's put everything into our formula, negative b plus minus into b squared minus 4ac, and then you divide everything by 2a. So let's remember that the value of a is 2, the value of b, it is positive 5, and then the value of c is negative 7. So now let us substitute. X is going to be negative 5 according yes, plus minus into the root of 5 squared minus 4. The value of a is 2, the value of c is negative 7. Now that you cover that, and then you divide everybody here by 2 into a, where the value of a is 2. And then you put this in your calculator, and then you're going to find that the value of x is going to give us negative 7 over 2, and another value of x is going to give us 1. But then let's go back to the question up there. When you go to the question, it says that determine the point of intersection of f and g where f is greater than 0. So if f is greater than 0, it means that we need to focus on the values of x that are positive. So this one here, It's negative. So the value of x, it cannot be negative 7 over 2. So that means our focus, it is where x, it is equals to 1 here. And then we need to find the corresponding value for this. So we know that at x, it is equals to 1. What is the y value? I'm going to use this. The y value is going to be negative 1 plus 1. Where I see x, I'm going to replace it by 1. Let's remember that. This part here, the formula is given by negative x plus 1. And then where we see x, we're going to replace it by 1. That's why we have negative 1 there. And then we put this in a calculator, but you can just simply simplify it. You will find that the value of y, it is equals to 0. So the points of intersection, what are they? It's going to be x is 1, the y value is going to be 0. So those are your points of intersection where the value is greater than 0. It's going to be 1 and 0. Now let's talk range. Let's talk range 4.1.4. What do we mean when we talk about the range? Remember that a range is a set of y values. And then in this case, they're talking about the graph of G. So the focus is going to be on the y value of the turning point in this case. Ne? So we're going to focus on the y value of the turning point. So when we write down our range, we're going to say that y is an element of what? Y is an element of negative 8. And then our graph is going to continue all the way up to positive infinity. Somebody can put it like this, or they can say that y is an element of real numbers as long as the value of y, it is greater or equal to negative 8. The value of y must be greater or equal to negative 8. So you just give one of the two solutions. You just look at your graph. Your graph is positive. It is facing upwards. You check the y turning point is here. We have negative 8. So your range, it starts from negative 8 here, and then it goes all the way up there, up to positive infinity. Sorry about that. So that is where our range comes from. That's how we determine the range. All right, moving on, let's look at 4.2. 4.2, they drew a graph for us, and yeah, let's see if we can answer these questions. They say the graph below, it represents the function defined by h, which is given by a divided by x plus q, and j of x, which is 3 to the exponent of x plus 1. The graph of h and j, they share the same horizontal asymptote. It's very important to read the statement before you can answer the question. And a, 2 and 2 is a point on the graph of h. No problem. Let's see. The first question, it says write down the equation of the asymptote of j. Okay, the equation of the asymptote of j, here it is. It's given. It's in the question. So you just write it as y, it is equals to 1. No calculations involved there. Determine the equation of h. Okay, this is 4.2.2. The equation of h, it's given by a divided by x plus q. Remember, what is q? Q is your asymptote. All right? And then let's read the statement. They say that the graph of h and the graph of j, they share the same horizontal asymptote. So this one is an asymptote for the graph of j, which means that the same one is going to be the asymptote for the graph of h. So already we have the value of q. So when it comes to the value of q here, you can just say this is a divided by x plus 1, because they share the same horizontal asymptote. And then on this side, we're going to have our h of x, and then we're going to look at our graph and then find any 2 points as long as they are on the graph of h. So the graph of h is this one. Let's just highlight it. So this is the graph of h, this one here. and this one. Yes. So we need 2 points that are on the graph of h. What are those 2 points? Here they are. So I'm going to call this one my x and this one my y. Where I see y, I'm going to replace it by 2, and where I see x, I'm going to replace it by 2. So you're going to have 2, it is equals to a divided by 2 plus 1. You transpose, you're going to have 2 minus 1. It is equals to a divided by 2. So 2 minus 1 is 1, which is going to be a divided by 2. When you multiply both sides by 2, you're going to have 2, it is equals to a. Therefore, what is the equation of h? You found a here will be 2, so you're going to have 2 divided by x. Remember, your asymptote is 1, so this is the equation of h you are looking for. So I'm just going to put it here. The equation of h is given by not a 2, so we're going to have 2 divided by x plus 1. Yes, that is our equation of h. Now 2.3.2, it talks about the range, so the question of the range comes back again. Now in this case, our graph is not quadratic like the previous question. We are dealing with a hyperbolic graph. So whenever I talk about a range and a domain, so let's just discuss those things. Normally the graph of h is given by a divided by x plus q. So when we talk about domain, when we talk about the domain, we look at this part of the graph, the x values. So we're going to say that x is an element of real numbers as long as the value of x is not equal to 0 in this case. And then when you talk about a range, we're going to look at this part of the graph, the q. We're going to say that y is an element of real numbers where y is not equal to q. So if you know the value of q, then you can simply write down the range of the graph. So our range here, we're going to say that y is an element of real numbers where y is not equal to, let's look at that, our q in this case, it is 1. So as long as the value of q it is not 1. So basically, what do we mean? We mean that if the value of y it is equal to 1, remember this is an asymptote. This line, the dotted line you see, it's an asymptote. So we're simply saying that our graph must not touch the asymptote line. So if our graph touches this line here, this is going to explode. It's going to be undefined. So our graph must not touch that line. So we're saying that the values of y are real. If you can look at your graph, the values of y are real all the way. Also this part, the values of y are real. However, the values of y are real for as long as our graph, this graph, it does not touch this line. This graph, it does not touch this line. Because if it touches this line, the whole thing is going to explode. So that is 4.2.3. Let's look at the last question here on question number 4. All right, we have another graph. So they say here, sketched below are the graphs of P, which is given by plus or minus the root of r squared minus x squared. G of x is given by mx plus c, and then f of x is given by a divided by x. F and P, they share the same point, which is -3 and 3. Okay, let's see if we can answer these. 4.3.1. So the first question, it says determine the equation of f. The equation of f is this one here. That is the equation of f. So the equation of f of x, it is equals to a divided by x. Look for any points on the graph of f. These are the points that I'm seeing. Any points on the graph of f, that's what I'm seeing. I'm seeing 3 and 3. So this represents my x and this represents my y. Then you substitute. Where you see y, you put the 3. This is equals to a divided by x is -3. then you cross multiply or multiply both sides by -3. So if you cross multiply, this is equals to divided by 1. A multiplied by 1 is A, then A is equals to -9. Therefore, our function of f is given by -9 divided by x. That is the equation here. -9 divided by x. Okay. And then 4.3.2. Determine the equation of P. Where is P? P is this one here. Let's see if we can determine that. So our P of x, it is equals to plus minus into the root of r squared minus x squared. Okay, same thing. We're going to go to the graph of P and find any 2 points. According to the statement, they said f and P, they share the same point, 3 and -3. So it means that -3 and 3, we're still going to use the same points in order to find the value of r squared on this equation. Where I see y, I'm going to replace that by 3. It is equals to plus or minus. It is equals to plus or minus, yeah, plus or minus the root of r squared minus x squared minus x, yeah, how it's -3, you square that. Get rid of the square on this graph. When you get rid of the square, it means that you must square this side, and also you must square the side. When you square both sides, you find this is 9. This is going to be r squared minus 9. And then you transpose, you're going to have 9 plus 9. This is going to give us our r squared. So our r squared is equals to 18. So wherever we see r squared, we're going to replace it by 18. Therefore, the equation P of x, it is going to be plus or minus. Where is our r squared? It's 18. And then minus x squared. And that is the formula for P. So let's just put it here, that P of x is plus minus the root of 18 minus x squared. Great. Okay. And then we're going to find the equation of G. G is our straight line here. G is our straight line. Okay, this one, it will require you to just try and think a little bit. Okay, let me not erase this information because we're going to need it. Yeah? So we have a straight line. Our straight line, it cuts the circle here and here. So in that case, what does it mean? A line drawn from the center to the circumference. What do you call this line? It's a radius, right? A line from the center to the circumference of the circle. What do you call this line? The radius. Now, what is the radius of the circle? Remember, from here is the center of the circle, so we've got 0 and 0. So it means that if we're looking for the radius, we have to come to this guy here. He's the one that is going to help us to determine the radius. Okay, so the radius of the circle is going to be the square root of 18. You're just simply going to square both sides so that you can find the value of r. So our r on this side is going to be negative the square root of 18, 0. And then here it's going to be positive square root of 18 and 0. Now you need a gradient. This is a straight line graph. So you need a gradient in order to find the equation of a straight line here. So what is the formula for our gradient? So I'm just going to erase this part. I'm just going to erase here so that I can find the gradient and also the equation of our graph. Okay, so we are on 4.3.3. So the gradient of the graph of G, I'm just going to put a small letter G there. The formula for the gradient is there in your formula sheet, y2 minus y1. You divide this by x2 minus x1. Which points am I going to use? I'm going to use these points here. I'm going to use this, let's call that A, and this one here, let's call that B. So the points that I'm going to use, yes. So I'll call this x1 and y1, and then I'm going to call this x2 and y2 so that my substitution can be correct. So my y2 is going to be 0, so I'll have 0 minus my, oh wait, I didn't put these points correctly here. I see that. So it's going to be 0 here and the square root of 18. Yes, 0 and the square root of 18. If this is x2 and y2, this is my x1 and y1. I see that. So it's going to be 0 minus the square root of 18. Yeah. Thank God I saw that on time. And then our x2 is going to be negative root 18 minus 0 there as well. You put this in your calculator, you will see that the gradient is 1. Now, the equation of a straight line, y minus y1 equals to m into x minus x1. So you can use any point. You can use this point, you can use this point, but let's use these ones here. Easier to work with because both of them are positive. So y minus the value of y is the square root of 18. So we're going to put 18 there. It is equals to m, it's 1 into x minus x is 0 there. So here I'm going to have y. It is equals to 1 multiplied by x, it's x. You take 18 to this side of the equation, it becomes positive, the square root of 18. So that is the formula for the equation of G. A little bit of work, but it's worth it. So here, what do we have? We have G, which is equals to x plus the square root of 18. The equation of the asymptote of the graph of f. Where are you, f? The equation of the asymptote of the graph of f. Now, the graph of f, it has two asymptotes. Please, let's not forget that it has two asymptotes. Your graph, it is not touching the x-axis and it is not touching the y-axis. That's where the two asymptotes come in. So when we answer this one, 4.1, 4.3.4, 4.3.4, our x-asymptote, where is our x-asymptote? It's somewhere here. The graph must not touch the x-asymptote, right? So the x asymptote, it is going to be 0. The y asymptote is going to be 0 as well. Where do I get them from? The equation here. The equation that I have of f, it is given by negative 9 divided by x. Let me just draw a straight line there. Negative 9 divided by x. I don't have plus q. My plus q does not exist. So if plus q does not exist, it means that I have 0. So I don't have the y asymptote. So this part here is going to be 0 there. So this part here is going to be 0. And then my x asymptote, remember, in technical mathematics, we do not have plus p. So it is always equal to 0, your x asymptote, especially for our graph, especially for our hyperbolic function. Ne? Yeah, it's a little bit messy here, so I'm just going to remove everybody. And then the domain. Let's remind ourselves about something. So here we had negative square root of 18, and then up there it's positive square root of 18. So automatically here it also becomes positive square. It's a circle, so the radius is equal throughout the circle. So how do we find the domain? The domain is focusing on the x values of our graph. So in other words, we are going to write down the restriction that restricts our circle on the x-axis. It's here. It's here. So our graph does not go beyond this point and this point. So in that case, it simply means that when we write down our domain, we're going to say that our domain is between negative root 18 and the square root of 18. Somebody can say that x is an element of, be careful of the brackets, use the square bracket, say negative root 18 and positive 18. Right there. Yes. And that answers 4.3.5. And that brings us to the end of question number 4. Let's see what we can do with question number 5. See you in the next segment. Bye-bye.